A very good morning to one and all. Dear 10th standard students, um, dear 10th standard students, this is your sir Sajid. Today, in the last class, as you know that as we have discussed about resistance of a system of resistors, in that we have discussed about series connection. Okay, we have discussed in detail, that is how it is connected in series, and also this is as I told you, this is very important for the 2 marks, right? And what are the things we needed here? There's some series resistors, for example R1, R2, R3 series resistors, and this is voltmeter is connected across the two ends, correct? And then emitter also connected, and the battery and the plug key, and this is the conventional direction of current. Okay, so these things we have discussed in our previous class. And then as far as the parallel connection is concerned, okay, parallel connection is concerned, this is also we have discussed in parallel connection. The R1, R2 and R3 resistors are connected in parallel. Got it. Resistors are connected in parallel, wherein the voltmeter is also connected. Right, voltmeter is connected, you can see, and then emitter is connected, plug key is connected, all the same as the series. But here you can see that the parallel, the resistors are connected R1, R2 and R3 in a parallel way, right? So next children, resistors in series, let's try to understand how exactly this resistors in series, wherein we detect very important formula, and this formula is very important to do the numericals based on the based on the series combination problems. And also we see the in this session we try to complete about one formula we detect based on the parallel resistance, and that through that formula also we try to solve the problems, and which are very important for the examination for 2 marks, right? As I told in previous class, these two diagrams also very important. Got it? This is you may get a question that kindly children, when I during the lesson, so when I tell you that during teaching, when I tell you, so these question, this the question maybe appears, this kind of question may appears which consists of 2 marks, what you have to write. So that thing, everything you need to write in a notes first, isn't it? Everything you need to write in a notes, because it is easy for you to study, right? So these two diagrams are very important as far as examination is concerned, as we have discussed in previous class. Let's try to understand how to detect the formula. How deduction of formula you won't get in the examination, but we come to know that is how exactly the series resistance formula we can detect. For that we can see one small activity. Look at here. Join three resistors of different values in a series. Activity 12.4. Join three resistors, as you can see here. You can see this. Join three resistors, right? Join three resistors which are in series, right? Which are in series, and with a battery and ammeter and plug key. So as shown in the figure. See, we can join here. You can see this one is three resistors, one, and this is second one, this is third one. Three resistors are connected. This is the battery is connected, emitter is connected, plug key is connected. Okay, plug key is connected. So all these things when we connect it, so when after that, see, insert a voltmeter across the ends of x and y in each ends, as you can see here for the each ends, right? Each ends x and y each ends, we for example these two ends we connect this voltmeter, right? So suppose the voltmeter, first voltmeter is taken as V1, second is V2, and third is we taken as V3. Okay, after connecting the voltmeters, when current is passed through this, right? Let's see what he has given. Okay, plug key and the circuit and the node voltmeter reading, it gives the potential difference across the series combination of the resistors. Let it be V. Now measure the potential difference across two terminals of the battery. So see, what you want trying to tell you means here in this picture, that is, suppose, just imagine that this resistor will give the resistance, of 5. Okay, this is gives the suppose 6, this gives the suppose 7. Okay, right. So you tell me that so if I add all these resistance, you say that 5 plus 6 is 11 plus 7 is 18. You say that, sir, 18 ohm is the total resistance. Okay, total resistance of these three resistors. Got it? Of these three resistors. Right. So after, one more important thing that we can able to see here is, so when we take the potential difference from one end, okay, potential difference after taking all these three, if we take now the potential difference from here to here, right, if we consider this, calculate the V, then also you'll get the answer as 18, correct, because this is 5, this is 6, this is 5, this is 6, and this is 7. So total answer across two ends also you get it as 18 potential difference. So from this what we infer, okay, what we infer from this, so we can infer from this only one thing, that so total series combination of the resistor, series of resistor is nothing but the sum of, okay, sum, okay, this is the sum of resistors. Got it? We can get it as a sum of resistors, right? So next, children, I hope you understand that. So in your activity is also given, what's given in your activity, that plug the key and measure the potential difference across the first resistor. Let it be V1, V2, V3. Suppose we have taken here in this example, V1 is 5, V2 is 6, and V3 is 7. So at the finally, when we take the total resistance of two ends, okay, two ends, so the two ends we get it as also the 18, right? So we can conclude that, we will observe the potential difference V is equal to the sum of potential differences of V1, V2 and V3. This is very important point. Can you able to, I hope you get it. This is very important point, children. Look at here. This is very important point. You will observe the potential difference. V is equal to the sum of potential differences, right? V1, V2 and V3. That is the total potential difference across the combination resistors in series, which is equal to the, as you can see that, which is equal to the potential, which is equal to the sum of potential differences of the individual resistors. For example, as I told you, this we have taken as 5, this we have taken as 5, this we have taken as 6, this we have taken as 7. So when we add all together, it comes as 18, correct? So sum of all the potential difference of the resistance, which gives the these two ends, correct, right, these two ends. So that's what he has given. That is, you can see here, we can write it as, this is very important, look at here, we can write it as V is equal to, I just maximize it so that you can able to see very clearly, right. Look at here, you can see here, this is called as an V1, V2, V1, V is equal to V1 plus V2 plus V3. What is V1, V2, V3? This is V1, V2 and this is V3, okay. So sum of all the potential differences. We know the formula, that is, what is that? Potential difference V is equal to I into R. We know the formula from the circuit, okay. We know the formula. This formula we have discussed in previous class. V is equal to I into R. So according to this formula, we can substitute the values on applying the Ohm's law, right? On applying the Ohm's law for the separately for the resistors, right? Ohm's law for separately for the resistors. If I apply that, look at here, it is given that already. Look at here, this is V1, this is V2 is equal to V1 first resistor, V1 is equal to I into R1 resistor, okay. V2 is I into R2, V3 is I into R3. So from the equation we can say that we need to add all that. IR is equal to nothing but, IR is nothing but here V, right, V. So total V is equal to, you can see that total V is equal to R1 plus IR1 plus IR2 plus IR3, right? IR1 plus IR2 plus IR3. Got it. This is very important, children. This you try to understand. This you can see that IR1 plus IR2 plus IR3. Okay. So IR nothing but we have taken it as series for S. Got it. So series which is nothing but for S. As you can see here, the series um, series S. So RS, right? RS is equal to R1 plus R2 plus R3, right? So this is a very important formula, right? Very important formula for the series of resistance, right? So this is very simple formula, isn't it? Very simple formula, that is RS is equal to, RS means S indicates here the series. RS is equal to R1 plus R2 plus R3. So you may get the, if you are lucky, that you may get this simple question in the board exam, that is find the total resistance of the resistors when it is these are connected in a series. Okay, few values will be given. When few values will be given, you need to write out, that is R1 plus R2 plus R3, how many resistors are given, their values is given, you need to add that and you need to write the sum. Okay, that's it. Fine. So it's very simple. Let's try to see now. Okay, try to see one example is given here. Look at here. One example is given. Look at, like, we try to understand that example. Fine. An electric lamp whose resistance is 20 ohm, right? Whose resistance is 20 ohm, and a conductor of 4 ohm resistance are connected to a 6 volt battery. Okay, right? An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm, right? Conductor of 4 ohm resistors are connected to a 6 volt battery, right? 6 volt battery. So here he has given very simple thing, that is two resistors are given. Two resistors he has given. So one, he has given that lamp consists of resistance of 20 ohm, right? And this consists of 4 ohm. This consists of 4 ohm. So by looking at that, we can easily tell me that total resistance, if I ask you the total resistance, so obviously the total resistance will be 20 plus 4. So total is 24, as you can see here. See here in the diagram. Look at here. Here in the solution, R1 is 20 ohm, R2. So formula we know that. What is the formula? Look at here. Formula is R is equal to R1 plus R2. So RS means R in series, 20 ohm plus 4 ohm, total 24 ohm. The total potential difference across the terminals of the battery, V is equal to 6 volt, because he has given V is equal to 6 volt battery. So we know that we need to find out the current, right? Current, we know that based on the formula, isn't it? Pyramid, I hope you understand, remember the pyramid. So V, this is I, this is R, correct? So here we need to find out the current. So I is equal to V by I, V by R, isn't it? V by R, got it. So I is equal to V by R. So when you substitute the values, so 6 divided by 24, which is nothing but 0.25, got it, which is nothing but 0.25 ampere. Why? Current we measure in ampere, got it, we measure the current in ampere. So I have written here, it is written that ampere. I hope you understand, children. Very simple problem, but remember that in the board exam, in order to confuse you, they will give this kind of a diagram. You should not confuse. So this is, suppose I'll tell you one more thing. Let's try to understand that. Look at here. Suppose here 4 ohm is given, correct? Here it is, bulb is given 20 ohm, right? Suppose one more resistor maybe he has connected here somewhere else, right? Somewhere else. For suppose this is maybe it's of a 10 volt. Okay, sorry, 10 ohm. So then in that case, the total resistance will be how much series? You need to add it all that. Okay, 4 plus 20, 24 plus 10, 34. Okay, if suppose one more is added here, so in series maybe it's 24 plus maybe it's 5 means you say that's total answer will be 29. Okay, but remember that directly you are not supposed to write the answer. First you need to write the formula. So what is the formula? You know the formula, rs is equal to, okay, rs is equal to r1 plus r2 plus r3. How many resistors are there? That much you write. Suppose they are given 3 resistors, you write rs is equal to r1 plus r2 plus r3. 2 they have given, so rs is equal to r1 plus r2. So 4 they are given, rs is equal to r1 plus r2 plus r3 plus r4. So write that, you need to write, and finally you need to add all that, and you need to write the total sum of that. Okay, very simple, isn't it? And next we shall see, look at here. Applying Ohm's law to the electric lamp of conductor separately, we get the potential difference across the electric lamp. So potential difference across the electric lamp also we can find out. How much, how it will be. So just now current we found out 0.25 ampere. So potential in difference, V is equal to I into R. Correct. Current into resistance. So that is 20 ohm into 0.25 ampere, which is nothing but which is nothing but 5 volt, right? And that across the conductor V2. So when we take the example of V2, so 4 ohm into 0.25 ampere current, same formula, that is V is equal to I into R. So 4 into 0.25 nothing but 1 volt. So 1 volt, why we have written volt here? Because potential difference we measure in volts, isn't it? We measure in volts. Got it, children? Next, look at here. Next, if you want to find out the resistance also, that you can also find out that. So resistance R is equal to V by I. V I found out, V I is given, that is 6 volt, and that is resistance is I, current is we just now found out. So what is the current? That is 0.25. So when you substitute that, again you get the answer as 24 ohm, right? I hope you get this. Okay, I hope you get this. Okay, let's without wasting the time, let's try to understand the parallel connection. You know that in series, the resistors are connected in series connection. Rs is equal to r1 plus r2 plus r3 and so on, the formula. And as far as the parallel connections are concerned, parallel, this you know that this is the parallel connection, we have discussed it. And suppose just we try to understand here, we take one more activity. Look at here, make a parallel combination of xy. See, we have made a parallel combination here, r1, as you can see that r1, r2 and r3, correct? These all resistors. Okay, sorry, look at here, r1, r2, r3, all three resistors are connected in a parallel. Okay, parallel. So for this, how we can deduct the formula? For this, there is a different formula. Don't get confused. So let's try to understand this formula. Make a parallel connection of xy, and having the resistors, that is R1, R2 and R3 respectively, connect with the battery, a plug key and ammeter as shown in the figure. So as usual, so ammeter is very important. Plug key should be connected in the circuit diagram, and there should be a voltmeter there, correct? So next, plug key and plug key and note the ammeter reading. Let the current I also take the voltmeter reading. It gives the potential difference V across the combination. The potential difference across each resistor is also V. This can be checked by the connecting the voltmeter across each individual resistors, right? So same thing here also. If we connect for the each individual resistor, that is a voltmeter, if you take the sum, right? If you take the sum, that will be equal. So look at here, how we can say that it is observed that the total current I is equal to the sum of the separate currents through each branch of combination, right? So we can say that I is equal to I1 plus I2 plus I3. So let RP means, remember here, P means, look at here, RP means, P means here parallel, P for parallel, okay, S for series, okay. So next, let RP be the equivalent means total resistance of the parallel combination of the resistors. By applying Ohm's law to the parallel combination of resistors, we have So I is equal to V by Rp, isn't it? I is equal to V by R. It's formula Ohm's law. So we can say that Rp means Rp P means parallel. On applying Ohm's law on the each resistors, when I apply Ohm's law to the each resistor, you can get it like this. That is I1 is equal to V by R1 resistor 1, I2 is equal to V by R2 resistor 2, I3 is equal to V by R3 resistor 3. So which is from equation. So V divided by Rp, okay, V divided by Rp, okay, R parallel is equal to V by R1, V by R2, V by R3. Okay, so here if you take 1 by R, okay, V by instead of V by R, if you take 1 by R, right, 1 by R, so 1 by, or you can write it 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. As you can see that 1 by R1 plus 1 by R2 plus 1 by R3. So this is, children, very important formula as far as parallel resistances, connection of resistors in a parallel is concerned. So just now we have seen the two formulas. So first formula is about series resistance. So series resistance formula very simple. Rs for the series, Rs is equal to R1 plus R2 plus R3 and so on, isn't it? And in the second parallel resistance, it is 1 by Rp per R parallel. Okay, 1 by Rp is equal to 1 by R1, 1 by R2 plus 1 by R3. Okay, now it's very simple. See, I'll tell you how. Before to see the problem which is given, I'll tell you something. Remember that. So, in as far as series is concerned, children, we know that when series problems comes, we simply add it. Okay, we say, put the value formula as Rs is equal to R1 plus R2 R3 so on, and we put the resistors values and we add up and we say that yes, this much ohm is comes as total as a series resistance. Okay, but as far as parallel is concerned, so suppose just imagine that three resistors are given in a parallel. Okay, in the diagram, okay, in the circuit diagram it is given three resistors are in parallel. So first resistor is 3 ohm, second resistor is 6 ohm, third resistor is 9 ohm. Okay, just imagine that 9 ohm. So in that case, what we do according to the formula 1 by Rp. So if you must see that, you must check that whether the resistors are connected in series or parallel. Okay, so after checking that, so when you get that these resistors are connected in parallel, so what you are supposed to do, you need to put the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. After putting that formula, you must substitute the values. So 3, 6, 9, I told you just now the resistors value. So how you are going to write as 1 by 3 plus 1 by 6 plus 1 by 9. Here we are not going to add. If you simply write the 3 plus 6 plus 9, okay, 12 plus 6, 18, that will be absolutely wrong, children, isn't it? So you must write 1 by 3 plus 1 by how much, 1 by just I told you, yeah, 1 by 6 and 1 by 9. And after writing that, so next what you are supposed to do, the same thing what you are done in the used to do in the 7th and 8th standard simple maths. So you need to take the LCM, because the since remember that when the fractions okay, right, when we add the fraction, if it is positive or negative, okay, we take the LCM of the denominators and we equalize the LCM to the numerator, and then we solve that. And if it is suppose is given in multiply, we directly multiply and keep. Okay, that's different. Let's try to see so how you can do that. So very simple question is given here, one question, that is in the circuit diagram given figure 12.10, suppose the resistors R1, R2, R3 have the values of 1.5, 10 and 30, as you can see in the diagram. Let's see the check the diagram, look at here, isn't it? So R1, R2, okay, and R3, R4 and R5, okay, look at you. So 30 respectively, which have been connected into the battery of 12 volt. R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, and we have connected to the battery of 12 volt. Calculate the current through the each resistors, the total current of the circuit, and see the total circuit resistance. See, this is very simple. How we can able to do it? I'll tell you. Listen to me. See, children, this R1 is given. Okay, R1 is given. R2 is given, which is given in parallel. Okay, sorry, can't able to write properly through this. um, I take your pardon. So look at here, these are in a parallel. Okay, parallel. First, what we'll do, listen to me very carefully. What I'm trying to tell you is very very important thing, because it really helps you to solve the problems. Try to understand it. So first thing you need to bear in your mind that, okay, when two resistors are given in parallel, okay, if we need to find the total equivalent resistance, right? First, R1 plus R1 and R2 is given, and you know that the formula, parallel formula, you know that 1 by R1 and by R2. So first we are going to do, these are the two resistors. Okay, these are the two resistors. So these two resistors, first what we do, these two resistors, um, first we reduce to one resistor. How we are going to reduce to one resistor? First we put the value of a parallel, put the formula of the parallel, and we take these R1 and R2 values there. Okay, and then when that value comes, okay, when that value comes, suppose this is 5 and this is 6. Okay, okay, 6 ohm anta ಅನ್ಕೊಡ್ರಿ. So if suppose this is the 5 and 6 ohm, when I substitute the values, right? So there's the answer comes. Or else I can say that, see, suppose this is the value A, this is value B, and the answer, when you parallel formula, when you put and substitute the value, the answer comes as C, suppose. Okay, answer comes as C. So this two resistors R1 and R2 will be reduces to 1. Okay, the reduces to 1, which has the value of C. I hope you understand. Suppose this is R3. Suppose if you take the value of X, and suppose R4 is the value of Y, and suppose R5 is the value of Z. So when we substitute the values in the formula of the parallel connection, so we get an answer as X, Y, Z. Suppose we can get the answer as P, suppose. So this register, all three registers will reduce to the only one register. Okay, suppose this value of P, and here answer, suppose, you can see that just now I told you this. Suppose this answer is C, is reduced to the one register, answer is C, and this reduced to the one register, answer is P. Okay, so now the total resistance, how we are going to find out? Again, these two will be in a parallel, C and P. Again, these two will we take and we put the values 1 by C plus 1 by P. Okay, and we take the LCM and find out the total value of the resistance. Got it? So finally, what I'm trying to tell you, so finally these two resistors are there. These two resistors are there. First we simplify into one. Okay, by applying the parallel formula. These three resistors are there. First we simplify into one by applying the parallel formula. After applying, when you reduces to the two resistors, again what you are supposed to do, these two resistors, again you must take a parallel formula and reduces to 1. Okay, so when you reduces to 1, that will be your answer. Okay, that will be your answer. Let's try to understand how it is, which is given in a question. So you can see that, children, a small question is given. Let's try to see. So he has given that in the figure R1 is 10, R2 is 40, R3 is 30, and R4 is 20, R5 is 60. Before that, this question we'll see that this question first. After we try to see that. Okay, in the circuit, look at here, 5 ohm, 10 ohm, 30 ohm. Okay, so solution, you can see 5 ohm, R1 is 5 ohm, R2 is 10 ohm, and R3 is 30 ohm. So potential difference, we know that 12 volt, V is 12 volt is given. So this also potential difference across the individual resistor. Therefore the calculate the current of resistors, we use the Ohms law, right? So in order to find out the resistance, we know the Ohms law, that is R1 is equal to V by R1. Okay, R1 is equal to V by R1. So so V by R1 is nothing but V is nothing but 12 volt is given, as you can see that, and R1 is given how much, 5 ohm, so 2.2 0.24 ampere current. Okay, I is equal to V by R. So here for the second we see I2 is equal to V by R2. So 12 by 10 ohm. V by R3. So 12 by 30 ohm. So current respectively comes the current as 2.4 ampere and then 1.2 ampere. Okay, then this comes as 0.4 ampere. Got it. So next we can see here the total resistance, the total current of the circuit will be I is equal to I1 plus I2 plus I3. So total we added here 2.4 plus 1.2 plus 0.4 ampere. So that total is equal to 4 ampere. Okay, when you add all that, I hope you know the adding of decimals. If you don't know, children, just simply add all those numbers and just from the left just see that is after how many numbers the decimal point is kept, you kept that number. So answer comes as 40. So when we put the value from the right, when we put one decimal point, it becomes 4.0. So 4.0 we don't write, so we directly write as 4 and 4 ampere. So ampere is nothing but unit of current. Okay, so total resistance, look at it, it's very simple. As I told you, total resistance rp is equal to 1 by 5 1 by, look at here, rp is equal to, you can see here total resistance which is given, rp is equal to 1 by 5 1 by 5 1 by 10 and 1 by 30, right? So here you know that as I told you, you must take the LCM, right, and you need to solve it. So that's all. Solving everything is not given here in this, isn't it? Here in this it is not given, so we just try to see that how it will be solved. Okay, how it will be solved. So first we need to take the LCM of, okay, LCM of 5 10 and 35, 10 and 30. So this will be multiplied by the 5, okay, isn't it? 5 ones are 5 twos are 5 6 are, isn't it? Next it is goes by 2, okay, 2, right? So 1, it is 2 ones are, 2 threes are, this is 3 ones are, got it, 3 ones are. So 5 into 2 into 3 we get it. So 5 into 2 into 3. So 5 2s are 10, 10 3s are 30. As you can see that the denominator you can get it as 30 as LCM. Right. So next what we are supposed to do? We need to equalize these numbers. Okay, we need to equalize these numbers to 30. So 5 how many is a 30? 5 6 are 30, correct, in first number. And 10 how many is a 60? 30, 10 3s are 30. And last thing, 1 by 30, 30 ones are 30. Okay, then 6 ones are, you can say again you have to multiply this, isn't it? So to the numerator, 6 ones are 6. Okay, this all things we have studied in the 6th and 7th standard. Once again I am telling you, those who don't understand, look at here, 6 ones are 6 plus 3 ones are, okay, again we have to come okay, so 5 6 are 6 ones are 6, 10 threes are 3 ones are 3 plus then 30 ones are 1 ones are 1, right? So it comes as 10, total 10, right? So total value comes as 10. So 10, okay, total value comes as 10. So 10 whole divided by the LCM we got it as 30. Okay, so 1 0 1 0 get cancelled there, or you can say that 10 ones are 10, 3s are 30. So answer we got it as 1 by 3, isn't it? 1 by 3, right? 1 by 3 as a parallel. RP it is, RP is equal to 1 by RP, it is 1 by RP is equal to 1 by 3. So RP is equal to how much it comes, we need to write the RP there. So if you write the RP there, look at it, if you write only RP there, you just inverse it and write it. So RP is equal to, it becomes 3 by 1, okay, 3 by 1, RP is equal to 3 by 1, 1 we don't write, isn't it, in the denominator. So directly we write the answer as a RP is equal to 3. That will be your answer as is given. Rp is equal to 3m. Sorry, unit you have to write. Rp is equal to 3 ohm. Got it. So this way we solve the problems. The next problem 12.9, that is, as I told you, just a hint that these we need to reduce the registers, and you need to find out the final value. Can you do it at home, and otherwise we shall discuss in the next class. So dear children, kindly all this stuff you must write in the notes, so that you can able to understand very neatly when you study your science notes. Okay, so we shall continue in the next class. Till then, take care, and kindly come on Saturday without fail, and come with your notes and correct it. If possible, I'll send you afterwards the one more activity, that also you kindly write and submit me on a Saturday. So do take care, very good care of yourselves. So this is your Sajid sir saying goodbye to one and all. Take care and bye bye.